Okay, letters, point symmetry. Point symmetry means you can turn it upside down and it looks the same. An A upside down is not going to look the same. It's going to have the point at the bottom. B will flip to the other side. C will open up on the other side. Da, 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 da. I hit H. H is my first letter that if I flip it upside down, it's going to look the same. A nice way to check on the smart board is to take that letter, draw it, flip it upside down, and it looks the same. Same thing with I. I will also be the same. And the last one is N. N is the one that I missed when I was scanning through, and I had to come back, try it again, because when you do flip it upside down, it does look the same. It's kind of the least obvious when you glance through. Next up, we've got a rhombus. ABCD is shown on the coordinate plane. If you're not sure what a rhombus is, that's okay. You don't need to worry about it. We can just look at it. Which one is a line of symmetry? Remember, a line of symmetry is a line that we can fold that shape over on and it will line up perfectly on itself. X equals 3 is going to be a line right there. Nope, that's not going to work. Y equals 1 will be a line right there. Nope, that's not going to work. X equals 1 would be a line right there. Hey, there we go. Now you can see point C, 1, 2, 3 away. Point A, 1, 2, 3 away that way. Those will in fact line up. So C is one of the answers. Y equals X is that diagonal line, right like that. Not a pretty line on that rhombus, so that's not going to be a line of symmetry. And finally, we've got Y equals 3. Y equals 3 is going to go right through the center. Again, we've got 2 above, 2 below, line up really well. So C and E are my 2 lines of symmetry. Finally, the last one. How many lines of symmetry does each figure have? So for this first kind of star-shaped one, you can go straight up and down, that's 1. You can go kind of diagonal or diagonal, those are 2 more, so that's 3, and then straight across, so that's 4. So you get rid of that so we can actually see it, but it is 4 lines of symmetry. 4 lines of symmetry. Now the rotational symmetry. How far can we turn it before we line up with itself? Again, because I have a smart board here, I can't turn the paper. I can instead make a sketch and turn that sketch. And when I turn it a quarter of the way, it lines up with itself. Degrees, 360 is a full circle. So 1/4 of the circle or 1/4 of the circle is 90 degrees. So this is a 90-degree rotational symmetry. Second shape. It is a hexagon, 6 sides. And we talked about a hexagon earlier as being made up of 6 different equilateral triangles. We know that each of those points inside is 60 degrees since we're dividing that 360 into 6 pieces. So let's talk about rotational symmetry since I already went there. So each of those, let me put them back on there. Each of those is 60 degrees. And if I take those and turn them, each of those turns will give me that rotational symmetry. So I've got 60 degrees of rotational symmetry. And now let's look at lines of symmetry. Where can I cut it in half? Well, I can cut it across right there. That's 1 line of symmetry. That's 2 lines of symmetry. That's 3 lines of symmetry. So I can go straight through any of the sides. And then I can also go angle to angle. So that's 1. Oh, man. Okay, let me go back, sorry. Let's talk about the midpoint of the sides, 1, 2, and 3. And then angle to angle, 1, 2, and 3. There you go, that's a better way of saying it. So we've got 6 different lines of symmetry.